Question 5.1. We need to show that the initial kinetic energy of the test vehicle is 700 kilojoules. Well, we know the mass is 1500 kilogram. We know the initial velocity u is 110 kilometers per hour. We need to convert that to meters per second, so we multiply by 1000 to convert it to meters from kilometer, and then divide it by 3600 to convert it to seconds from hours. So the kinetic energy is a half mv squared, a half times 1500 the mass, and the velocity, which is 30.6 squared. When you solve that, you get the kinetic energy to be 700 kilojoules. Question 5.2. We need to calculate the component of the momentum of the test vehicle in a direction along the line of the safety barrier, and we need to give an approximate unit for the answer. So we're calculating momentum, and momentum is mass times velocity, but we need to resolve the velocity. So the initial velocity coming through, we need to resolve that horizontally using cos 20 degrees equals adjacent over hypotenuse. The adjacent is the h horizontal velocity over the that we're looking for, and 31 degrees is the hypotenuse. So cross multiply by 31, we get h equals 31 cos 20. So that's what this is going to be. This is your v is 31. So that will be 31 cos 20 times the mass, because momentum is mass times velocity, and that will be equal to 43695 kilograms meters per second, which is 4.4 times 10 to the power 4 kilogram meters per second. Force times time is change in momentum, and the change in momentum is what we've got here, which is then 4 times times. This is Newton seconds. Mass times change in velocity. So that's the unit. Either that one or this one will do. Question 5.3. We need to show that the kinetic energy lost in the collision is about 80 kilojoules. Well, kinetic energy before collision is 700 kilojoules, and the kinetic energy after collision is going to be a half mv squared, where v after collision is going to be 30.6 cos 20 degrees, and working out the v, that turned out to be 28.7 meters per second, and kinetic energy after collision is going to be a half mv squared, where m is 1528.7, and that will give us 618 kilojoules. Changing energy will be 700 minus 618, and that will give you 82 kilojoules. You could also calculate it by calculating the speed perpendicular to barrier after, which is 31 sine 20, because you're resulting in a perpendicular direction, and that will give you 10.5 meters per second. The loss in kinetic energy is a half mv squared, so that will be a half 1500 times 10.5 squared, and that will be 82 kilojoules. Question 5.4. We need to deduce whether the safety barrier will pass the test. So we're looking at the work done, which is force times distance, and force is going to be work done over distance, and that'll be 82,000 divided by 1.5, and that's 55 kilonewtons. So therefore force is less than the braking force, so that's yes. So now the braking force was 660 kilonewtons. Another way you can look at this calculation is to say the work done by barrier is going to be 60 kilonewtons times 1.5 meters, because work is force times distance, and that will be 90 kilonewtons, which is greater than the kinetic energy of the vehicle. So another way of doing that is to say the energy loss is going to be 8 times 10 to the power 4, because that's the energy loss there. 8 times 10 to the power 4 will be equal to 4 force times distance. That's kinetic energy here. And the work done is going to be kinetic energy, which is equal to force times distance, and force is 660 kilonewtons. So if we find D, that would be 8 times 10 to the power 4 over 6 times 10 to the power 4. And 10 to the power 4 we cancel out, because you go 10 to the power 4, 10 to the power 4. And 8 over 6 is 1.35 meters. Yes, the car will not move 1.5 meters. question 5.5. We need to discuss which type of barrier would cause less damage to the dummy in the test. Well, so the first barrier is safer with concrete, no energy transfer to barrier if it does not deform. Therefore, it is elastic collision, and therefore change in momentum is going to be 2mu because 2 times initial momentum, the initial momentum going to the left with the speed and then coming back in the opposite direction, and therefore force is mass times change in velocity over change in time t, then change in time t. Force experience will be greater because if the change in momentum is greater, the force will be greater.